During the course of my dance pad building project, I had a few people contact me and say they had old metal dance pads that had stopped working and asked if I had any advice on how to fix them. This is something that I've done a few times, so I wanted to make a video about it and show you my process for doing so. So behind me, I have the pads that I built. We're not going to be talking about those today. Pardon the slightly janky camera work here. So here I have a Blue Shark pad with two of its panels replaced, so pretend these two look like those two, and a Cobalt Flux pad, which also probably looks a little funny. I installed an arcade kit, which these black panels are raised slightly so it recesses the other ones, and for some reason I took out the decals on the other panels. I guess at the time I thought it looked good. This was my dance pad for many years, then this was for many years after that, until I built those. So I'm kind of in, I'll show you around my dance game room. I'm in mid-transition from Pump It Up mode to In the Groove mode. This is the corner where I tuck my machine away when I'm not using it. So then I just play on this TV using those pads. Anyway, so what I'm going to do today is show you just a general way to build a control box for an old metal dance pad. This should work on most old dance pads. I certainly can't say that it works on all of them, but I've tried this process for Blue Shark, for Cobalt Flux, and I know it would work for others too. So, the basic idea is that these pieces of equipment are just very simple bits of machinery that don't really have any control circuitry in them. On the front of the Blue Shark pad, there's a D-sub connector, or VGA connector, whatever you want to call it. There's a similar thing on the Cobalt Flux. I actually just noticed a bit ago that these are actually different genders of connectors. This one's female, this one's male, or however you designate that. But basically what you can do is, if the control boxes that connected to them stopped working for some reason, you can just get a VGA cable. I have one here. I'm going to be cutting this open, plugging one end into the Cobalt Flux, and wiring it up to some control circuitry in between. Now these came with a PlayStation-compatible control box. So this has the VGA connector on one end, and the PlayStation connector on the other end. These were particularly notorious for just failing after a while. I tried all of the Cobalt Flux control boxes that I have, and all of them do not work anymore. So my only option if I want to play on this pad is to create a new control box. So I have OpenITG running here on the test input screen. I bought some very cheap USB controllers off of Amazon. This seemed like about the best choice. I could get a pack of 2 of these for $12, so it's a very inexpensive option. Other options would be, you could use a UHID. I have one right here. This is a UHID Nano. Takes a USB cable and a ribbon cable that goes to whatever you want to wire it up to. I have this silly little thing here which I use for selecting music when I'm playing in the groove. It basically mimics the buttons that would be on the front of the cabinet. This is just sort of a test controller to see that I could wire it up to one of these. And actually, for a while, there was a time when my Blue Shark pad was out of commission for some reason. When that happened, I was playing on this one, and I wired up a custom control box for it using a UHID. So this is just VGA cable that can plug in here, and excuse the camera work again, this is kind of hard to do. A bunch of splices on wires that go to this connector, which would plug into the UHID that I showed you over there. That device costs a little more than you necessarily need to pay for this sort of thing. A controller like this will work just fine. So the idea is, I'm going to open this up, wire it up to the appropriate connectors on here, and that will function as the control box. And this has a USB connector on it. Boy, it is hard to do this one-handed. Yeah, USB connector there. So instead of having to go through some sort of adapter from PlayStation to USB, right, that's another thing I'm going to talk about. Yeah, you can just go straight to USB from one of these. So here I have my old Blue Shark control box. Sorry, it's all coiled up. So this has the other type of VGA connector on it, and it might not look like much. So the control box is actually inside here. I was kind of surprised by this. Let me get this camera on a tripod, and I'm going to take this apart to show you. Alright, so this is going to be a little bit of a challenge to do with the angles. I'll try to keep this in shot as much as I can. So just 2 screws on the top here. Sorry, I'm covering it with my hand. Not much I can do about that. Right, so take those out. And underneath this cover, come on now, there's a little tiny circuit board. Yeah, that just lifts out. And a bunch of tape in here for some reason. Anyway, this is the actual control circuitry for the Blue Shark pad. I thought at one point that it was actually integrated into the... oh boy, I don't know which way this goes together now. This might have been a mistake. Okay, so it'd be like this, in there. Okay, cool. I had thought that the control circuitry might have actually been integrated in the pad, but no, it's in the tiny little connector. There we go. Alright, so let's just put that back together. So what I was saying about adapters a moment ago is that I have this red octane adapter over here, which has served me very well over the years. These are not available anymore. These were actually kind of specially made, so it takes PlayStation here and converts it to USB, or I believe this is like, is that GameCube, and this is something else. I'm not sure what exactly. But that was a particularly noteworthy adapter. I have some generic ones. This is just says PSX to USB. I forget where I got this, Radio Shack or somewhere. Yep, Radio Shack. So that takes the same connector. The thing about those is that the way it maps, that thing, there's a dance mode to this adapter, which you actually have to put in a special button sequence. I believe it's up, start, and select. Just hold those and it puts it into dance mode. So what that does is it changes the way the inputs are interpreted. When you're not in dance mode, it basically treats these 4 arrows as a D-pad. The problem with treating them as a D-pad is that left and right and up and down would not be able to register together. But in dance mode, they can register in any combination without causing any problems. But these little generic adapters, like those, they don't have a dance mode, so like it'd be impossible to register up, down, or left-right jumps. I'll talk a little bit more about that later. Anyway, so let's go look at the Cobalt Flux pad. So here's the front of the Cobalt Flux. The first thing we need to know is what pins on this connector correspond to which panels, and which one is the common wire. Because basically everything that happens in here is just to join pairs of pins here to say that we're making contact with the up arrow, the left arrow, the right arrow, the down arrow, or even these corner panels if you want to wire those up for something. Now, this is where multimeter comes in. So having one of these, any kind of continuity tester or anything like that, it's very handy. I'm not an expert in these things. I just pick some random resistance value, make sure those are plugged into the right ports. So I happen to know. So my technique for this is to use paper clips as pins. Just insert them into the holes here. I think I happen to know that these 2 pins here, let's see, is it these 2 in the center row or is it the bottom row? 2 pins right next to each other correspond to the up arrow. So let's see, this is really hard to do from this angle. I'm going to have to go around to the other side. So from over here, I'm going to basically sit on this up arrow and touch those 2 paper clips with my probes. Okay, so I have those in the wrong positions. I think it was actually the bottom row here, or top row, depending on how you look at it. Let's see. Boy, this is really, really hard to get on video, because I'm on the wrong side. I need to get everything in shot at once. I don't know how I'm going to do this. Can you see that screen at all? Probably not. I need a prop for this. 1 second. Okay, let's just try a different camera angle. I think you can see everything important here. So, got my paper clips in the appropriate places. I'm going to put these probes on here and put my knee on the up arrow, and you can see the resistance change. It goes down to 0. So those two pins get joined when the up arrow is pressed. So basically, the information that I get from that, and it would just be sort of a trial and error process to figure out which pair is which. So basically, I'd run the test like this. If that fails, I'd move the paperclip over by 1, run the test like that. It's a bunch of pins to go through this process, but yeah, basically just test every single pair. So, go down the rows, all the way there, go down this row, go down this row. Once you get to here, just move this up 1. It's a little hard to do this. And repeat the process. Check every pair from then on, and eventually you'll get a pair that changes when you press a panel. So since I know that these two pins join when the up arrow is pressed, I know that one of these two pins is the common pin that will get joined to any of the 4 arrows when they're pressed. So I'm going to just go ahead and take a guess and say it's the outer one, probably. So I'm going to move this 1 over in this direction. So these are 1 pin farther apart. And let's see if that might correspond to any of the, oh boy, camera angles. This is a real challenge. So that's a pretty awkward process, kind of heavy on trial and error, because you have to just try every single pair of these to figure out which pin goes where. On the cobalt flux pad in particular, there's actually a shortcut that can be taken here. If I were to take this apart, this will work on any pad where you can directly access the contacts on the panels. The Blue Shark would make this a little bit harder because it has actual arcade sensors in it, and you'd have to cut the wires or find some point where you can probe the bare wire to see what the connections are. But what I can do here, since I have the arcade kit on this, I have to take these brackets off first. Ooh, it is rusty under there. But what I can do here is if I take off the panel, I can just find out which pin on the connector joins to the top part and to the bottom part. So once I get this off, you'll see what these things look like on the inside. If you have one of these pads, I'm sure you're already familiar with this. But yeah, so the way the pad works is it's basically just each one of these panels has a wire going to the top part of it, then that presses against a large metal contact plate on the bottom. So that's how contact is made in the panels. So you have to kind of be careful taking these off because you don't want to break the wires. They're all on the inside, I believe. I don't actually remember super well. It's been a long time since I've taken one of these apart. So all those screws out. We got the Velcro. Right, so the plexiglass panel can come off separately. The decal would go in between these two if this had any. So I believe I can just gotta feel around here carefully, make sure I'm not breaking any of the wires. Okay. Wires are in this corner. Yeah, so up underneath here you can kind of see the outline of where the wire from this runs down the pad. Anyway, so be careful not to break this. If you do, it's no big deal, just splice it back on again. So we're going to see which of these is which. So I'm going to try the top right, bottom right pin, the outermost one against this. That is indeed the base plate, because that went, I don't know if you can see from there, but those two are connected. So then this would connect to the top portion. If I get these to touch properly. Come on now. Yeah, there we go. Okay. So now I know that this pin, all the way on the right here, in this corner, that's the common one that goes to the plate that's all, that goes to all the panels. So then I could take off each of these panels and run the same check between any pin on here and the top of the panel. So that's a way I could take a shortcut with the cobalt flux and not have to do every single pin pair, because it's a little hard to get the multimeter probes on the paper clips and stuff. So with the Blue Shark, I would just be poking at pins in the connector on the pad instead, and that's even actually a little bit harder to do. So yeah, it's kind of a pain to get a pin diagram together for these, but yeah, what I do is I use a text file and note down what each pin connects to, and then that takes us to the next step of the process. So the next thing to do here is to take this VGA cable and cut it in half, because one end will connect to the dance pad, the other end will be wired into the USB controller. So I can just get rid of this end unless I want to do this again, basically. So one VGA cable gets you enough for two of these if you need it. So strip these wires down. There's a whole ribbon of stuff inside the VGA cable, of course. So I need to determine which wire goes where, basically. So you could do this all at once. You could cut the cable in half. Boy, this is going to be a pain to strip. I'll do what I can. See if I can do this without damaging the wires too much. Let's see, how close am I? Yeah, I'm through part of it. Anyway, so you get in here and figure out which wire goes where. So what you could do, there we go, this has a sort of braid around the outside, and then aluminum foil wrapping up a bunch of other stuff in here. Oh, are these not color-coded? Well, some of them are. This is strange. This is different from how I'm used to VGA cables looking. Okay, so this might be a little bit more of a challenge to work with. Got these really thin little cables. I don't know if you can even see them very well in there. Some of these seem to be sheathed in metal. So it might be that the metal sheathing is active and corresponds to some of the pins. Then the wire inside corresponds to different ones. So this could be very interesting. Yeah, the last VGA cable I worked with was a little bit different from this on the inside. How do I even... Trying to, I guess I have to unroll this? Okay, so here's a wire. Sort of a pale green one in there. Alright, so anyway, I'm going to unroll these wires, strip them individually, and figure out basically which wire goes to which pin and how that corresponds to the map that we made with the pad down there. Alright, so I separated these wires, stripped them all down. These are very thin, delicate little wires, so stripping them was a little bit of a challenge. And anyway, so basically what you can do at this point, you can skip some of the earlier steps I talked about and just do this instead. Just plug in the cut-in-half VGA cable into this and test pairs of these wires with the multimeter. Red in this case, and I think this will be consistent in all VGA cables, red will be the common wire, at least for the cobalt flux. So if red and green are connected, then it's the up arrow. Red and blue is down. Now here's where it gets a little bit weird. Red and all this uninsulated nonsense that I cut off here and thought I wouldn't need, red and that are the left arrow in this cable. Then red and black is the right arrow. So I'm not sure exactly how the VGA standards work. The wire colors at the very least are not consistent. This other cable that I made for this purpose, this is not like this. So what I have spliced here, if I can get to the appropriate part of this, so this one has the red, green, and blue cables as before, and I think those go to the same places. But on here, red and brown is left, and red and black is right. Or maybe it's red and black is left, red and brown is right. And let's see, black on this cable corresponds to, I need a pointer. I'm not sure how well you'll be able to see this. Let's see, make sure I don't lose my place here. Alright, so this is the red pin here. Green, blue, then on this cable it goes black, brown. So counting from this side to that side, those are the ones that actually carry the signal. On this cable, so let me get this in the same orientation. I believe it was like this, yeah, so it's red, green, blue, uncolored, black. And the uncolored one is joined to the base, the outside. That is not the case for this cable. So just different oddities of different ways VGA cables are constructed. I don't know what in the VGA protocol each of these pins actually goes to. Anyway, so different VGA cables may be different on the inside is basically what I'm saying. But this should all work. Now that I know the colors, even just soldering to this should be fine, since it is isolated from the other wires. I have individual connections. Now I do note that even though there are 15 pins here, plus an outer sheath, we only have 1, 2, 3, 4, 5, boy, these are hard to count. 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9 wires? Can that be right? 10 wires? Yeah, 10 wires if you count the outer one. So I guess 5 of these pins just don't map to anything, which is kind of strange. I guess those are just unused for VGA connections. But anyway, this is enough for my purposes. So with that map out of the way, let's take a look at the actual USB controller. Alright, so we have our wire that's going to connect to the cobalt flux. We know how these wires map to it. So this controller is going to be the thing that interfaces between raw wire connections and USB. So I have this, let me see if I can tilt this back. I have this connected up here. I've already mapped this to left, right, up, and down. So basically I just need to solder some of those wires onto each of these button connections and some common wire inside the controller. So let's take this apart. Totally fine to take it apart while it's connected. That's no problem. In fact, we need to do it for this. Let me just get all these screws out. Alright, screws are loosened, cover should pop off. Now this can get a little bit messy with all the buttons and things. Inside this I think I need to unmount the shoulder buttons. Remember where these pieces go in case I need to put this back together. I've already done this once to take a look at the inside of this to make sure it would be suitable for this project. So just lift out the circuit board gently. And so here's the circuitry. Got contact patches on the front of this for the buttons and D-pad stuff. So let me demonstrate something. I'm going to take, let's see, so this is the D-pad, I think. Which thing is that? Is that the D-pad? If I can flip this over and look at it without everything spilling. So that's the D-pad. These are the buttons. So this little membrane thing just has like things you can press. These black pads on the bottom make contact between like these zigzaggy lines here, so that it registers as a button press. So I can just stick this on here, and if I pointed that at the screen, let's see if I can get these in shot here. So I'll just stick that on there and press it. If I target better. Alright, yeah, so controller 1 up, and then this is menu up, right, I mapped the D-pad to menu stuff. So if I were to press, let me take the D-pad, one of these, so stick the D-pad thing on here, I'm going to press left and, there we go, left and right at the same time, it just doesn't register. So with both pressed, sorry, I pulled that out of shot. So press left, press left, it's fine. Press right, it's fine. Press both, it just gets nothing. So that's what I was talking about with having to basically, what am I trying to say? Sorry about that creaky tripod adjuster. That was the problem with the USB adapters from PlayStation controllers. Basically, they wouldn't register. For DDR pads, they actually used the D-pad directions for the directions on the pad. But yeah, with like this circuit board, it just doesn't register separately. So that's why I'm choosing to map to these buttons here, basically. If you wanted to get a second pad in here, you could hypothetically do like shoulder buttons and start and select, and use one circuit board for 2 pads. You wouldn't have any room for like menu navigation buttons, stuff like that. Anyway, so what we need to do is figure out how to solder the red wire on here onto some pad. I don't know which is the common, maybe this. And the green, blue, black, and uncolored ones onto the appropriate directions here. This is going to be tricky, and I'm going to need to get to a better place for soldering stuff. So a helpful thing to do at this point is to know exactly which pads I'm soldering to. I've taken just some random length of wire, and just taking a glance at this, it seemed like a pretty good guess that this right here was going to be the common ground line, and then there are these 3 little pads here for each one for the buttons, and then another one there. So if I just like put this wire right here, so I'm just holding it onto that common place with my thumb. If I touch there, that counts as that counts as that. So up, down, left, right. So just with a little length of wire, with this device plugged in, and some kind of program that'll show you what gamepad input it's getting, I can tell which pads I want to solder to. So I know that this is common, this is left, this is right, this is up, this is down. So simple enough. Alright, let's see if I can make this work at all. So since I have an uninsulated wire here, I foresee an issue. Let me zoom in a little bit here. I foresee a possible issue where if I solder it to, this needs to go here. I don't know how well you can see that. This touches that pad. I foresee a possible issue where, like, if this flexes around, it might make contact with something else. And the way I cut these wires, this one came out a little bit short. So what I think I'm going to actually do is take an extra, just little tiny length of insulated wire and connect it to here so that I can work with 5 insulated wires here to solder to this. Then I'll have enough length that things won't just accidentally make contact there. I would do this a little nicer if this were for some sort of permanent setup, but this is just for demonstration purposes. I'm sure you can all do a better job of this than I'm doing here. So, got my soldering iron heated up. Soldering's always kind of fiddly. Kind of need more hands than I actually have for it, so I'm going to try to twist these together and then just flow some solder around them to get those 2 joined. It doesn't have to be super precise. Alright, so how am I going to do this with only 2 hands is the question. So let me untwist this a little bit. Need to remember to stay in the shot. Everything becomes a little bit harder to do when I need to get it on a video camera. Alright, so I'm just going to fray these a little bit so they'll twist together better. Twist those together. And again, this will be different for different VGA cables. You might not have to deal with this issue at all if you have a colored wire for that particular pin, but for some reason this cable does not. Alright, so I'm just going to kind of set this here and hope it stays well enough. That seems good. Alright, so I'm just going to heat this joint, apply some solder to it. I've already tinned my iron. Let me do that a little more. Just want to flow some solder around that. I'm hoping it'll just stay if I just set it there. Solder is sticking. This is kind of making a mess. I need to actually hold this, don't I? Yeah, it's just not heating. Alright, so soldering's kind of hard. This might work eventually. Okay. Is that joined at all? Not really. Alright, let me figure out a way to do that better. Alright, so I've clamped this onto an assistive device that should just hold it firmly in place. I've twisted this together again. Hopefully I can just heat this up and flow some solder around it. There we go. That looks... okay, so that's... it's making a bead, so it doesn't seem to want to flow around one of these wires for whatever reason. Okay, so that's really strange. One of these just does not want to take the solder. Alright, that dripped. Yeah, so it seems like a solder connection here just doesn't work. I wonder why that is. Okay. So is that connected at all? Maybe a little bit. I mean, yeah, it's staying together. Okay, that's gonna have to be good enough, I guess. That's not very good though. No, that just pulls right apart. Huh. So since that refused to take solder for whatever reason, let's instead use an uninsulated crimp connector. So I'll just stick that in there, crimp it down with this. So that should be firmly connected now. There we go. Crimp the other side. This is a little awkward to do. Hold you there. Okay, so those should be mechanically joined now. Electrically joined. Both, I guess. Yep. Alright, so that's kind of janky, but it'll work. Alright, so now I have just 6 wires that I can solder with. So I can clearly see that the rest of these are copper, so they'll take solder much better than whatever the heck this is. I guess it's some other metal or like treated metal or something that solder just does not stick to the same way. Alright, so the first one I want to solder is red. Red goes to the common thingy. So I'm going to want to use this device somehow. Alright, this is going to be tricky. How will I do this exactly? I need to hold the red wire against that pad. Let's see if I can just sort of clip these both in together. I'm used to through-hole soldering. This, doing it on the surface pad is not what I normally do here. Ugh. Okay. So if I hold this open, I need 3 hands just to connect this to the third hand. Alright, so get that in there. Get this from some angle. Ugh. Well, it's a mess, but it'll have to do. I hope this works. Okay. So, just want to heat that up. Apply some solder to it. Let's see how this goes. Whoa. Okay. That didn't go exactly the way I wanted it to, but it's connected. And that hasn't bridged over to any of the other contacts. Okay, good. So solder sticks to that nicely. Yeah, so that's firmly connected. The wire's still kind of fragile, so I don't want to put too much stress on it. Alright, so this weird one needs to go there. Let's see. I'm sure there have to be better ways to do this. Okay, so I've seen one guy online hold the solder with the same hand that he's holding this. Let's see if I can make that work. So I'm going to hold... What fingers do you use for what here? I don't even know. Alright, this is super awkward. Alright, I got it on there with the clamp. So I've cropped the wire very short because I have a pretty small pad to solder to, very close to something I don't want to connect it to. So let's see if this works at all. Heat, solder, whoa, made a noise. Okay, that's not a good joint, but maybe I can fix it. There we go. It's not great. But I'm a little wary of putting any more on there because I'm afraid I'll join to this. Now this is hanging by just a thread here. I wonder if I could just sort of gently nudge it in there and add a little more to this. Well, I've disconnected it. That's not what I wanted to do. Oh, this is a mess. You know what? That'll have to be good enough. It is connected. All right. That's 2. Alright, so here's green going on. That's the up arrow. Angle. Probably blocking the camera doing this. That did not stick. It keeps making popping noises that are slightly concerning. Okay, well that's connected. Alright, blue. Blue is the down arrow. Tin this. I'm running out of angles that I can approach this from. There's that popping noise again. Why does that always happen? Alright, blue's on. Red has actually come off, so let me see if I can just sort of get this on here and just kind of melt it back into there without messing with anything else too much. I mean, that kind of works. Sure, it's connected now. Alright, finally black for the right arrow. I don't know how well you can see any of this. It's hard to tell how good my camera angle is. Just get that in there a bit. And join it. Okay. So all that blundering in there is basically just to demonstrate that even if you're not super great at soldering and don't know extremely well what you're doing, you can still get this done. Like, I am not a soldering expert, but with a little bit of fiddling, that should be a perfectly functional control box. Let's plug it in and give it a try. Alright, let's see how we did. So I got this plugged into the USB port here, and I'm just going to plug it into the cobalt flux. One-handed if I can manage. Eventually, there we go. Okay. So, left arrow, right arrow, up arrow, down arrow. Good. When I stood on the... Okay, that's strange. The down left arrow also triggers that. Okay, so that's... Oh. That's interesting. I might have a wiring problem here, actually. Okay. So when I step here, that also triggers that. I think that's just to do with left was the arrow that had the unsheathed wire on it. I wonder if, like, that particular VGA cable just has some wires crossed, or if I did that when I was clipping it and stripping the wires or something. Well, this will still be playable. This won't be ideal. Alright, so perhaps a different VGA cable would be better for this. I just bought the cheapest one I could find. Anyway, so let's play a game with this. Demonstrate that it totally works. I could, if I wanted to, I could put the thing all the way back in its casing. Let's see, is this adjusted right? Mostly. There we go. I could put the thing all the way back in its controller casing and use like the start and select buttons and the D-pad to navigate menus. I haven't bothered to do that just for this demonstration, but it's totally something you could do, so you wouldn't have to navigate with the keyboard for stuff like this. I'm not going to bother putting on shoes for this, so I'll just play something really easy. Oh. works. That was a terrible performance. There are a few reasons for that. I'm not wearing shoes, I'm not warmed up. I'm not going to just make excuses for this. Part of that, I was definitely getting some misses on the down arrow. There's a reason I don't play on this pad anymore. The contacts on the Cobalt Flux can get dirty. I think the down arrow was dirty, because I was getting some misses on things I was definitely stepping on. But hey, this demonstrates that it works okay. A little bit of cleaning on this could make it perform much better. Anyway, yeah, so that is functional. That's how you make a control box for an old dance pad that doesn't have one that works anymore. Yeah, so like I said, I think this process generalizes to pretty much any dance pad that has a standard connector that works in that way, where basically just like each panel joins two pins together on whatever the connector is. So just get the appropriate connector, maybe not whatever VGA cable I've chosen here, because it does have that problem with this and this also registering as left, just because some of the pins are joined together. So yeah, what I learned today is not all VGA cables are created equal. But yeah, just the basic principle. Any random cheap USB controller, solder to the pads that go to the buttons, just map those. I had pre-mapped them for this. Map those to whatever you want in StepMania or OpenITG or whatever you're playing, and you're good to go. Yeah, so I hope this was helpful. Sorry it was a little bit derpy. It was put together in a little bit of a hurry. But yeah, I hope the information was good. If I forgot to cover anything, or if you have any questions, then please hit me up in the comments. I'd be happy to elaborate more. Because I've done this a few times. This is like the 4th time I've done this process, I think. You'd think I would have gotten better at soldering by now, but it's a hard thing to do. I'm going to stop looking at that score, because that score is terrible. Anyway, yeah, so hope this helps. Let me know if you have any questions.